So hi everyone. Thanks for joining our webinar today. So Predictive Analytic in Minitab Statistical Software. Okay, yes. If let's say you want this material, please drop your email in the Q&A box or chat box. So after this webinar, I will send to you. Okay. Okay, so I'm Sulawati. I'm the technical support specialist at Basic System. Basic System independent representative Minitab for Malaysia, Singapore, and Batam, Indonesia. So here a few housekeeping notes before we begin. We have a Q&A session after the presentation. So please submit any question you have and we will try to our best to answer them if have a time. If no, we will answer afterwards by email. So we recommend view this webinar on your laptop or PC for the best result. Please fill out our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. So we record this webinar and upload to our website www.busy.com and our YouTube channel Minitab Malaysia and Singapore. So there's no problem if you miss anything or want to review afterwards. Okay, so Minitab was developed in 1972. So today Minitab in market more than 50 years. So since then, Minitab come up with the diversity of product. There will be our Minitab Connect for the data transformation and the dashboard. And then we have our flagship product, Minitab Statistical Software, where you can see for the statistical data analysis. And then we have the SPM, it's a software predictive modeler. That one is for machine learning and the predictive analytic. But now some of our algorithm inside the SPN are available in the Minitab Statistical Software. And then we have others, we call it, this one is a Minitab Model Ops to help business analysis and the engineer successfully implement their own machine learning and predictive model. Means to say that if like, you have a machine learning models or something predictive analytic after this, you will use another what is we call it Minitab Models Ops as a BR, like the dashboard to implement that the models. Okay, and then we have the Minitab Workspace. Minitab Workspace is something like for visualization, like template at VSM, FMEA, maybe we have a DMIC template and so on. And then we have the Minitab Minitab Engage. It's complementary with the dashboard. Some from them also have the like template like VSM, FMEA, but the another thing it's a good for the Minitab Engage. It will be different with the Minitab Workspace. It will have the dashboard where you can share your summary, your project, and so on. And then we have the Education Hub. It will be the online base, consists of few models like statistical inference, regression, DOE, and so on. And then we have the real-time SPC. This one is something like you can monitor and alert in the real time, allow for immediate action when quality varies, saving both time and the money. So today we focus on the Minitab statistical software with the additional model. We call it division. It's a predictive analytic. But if let's say you want interest further to know others product, feel free to contact us for more information on that. Okay, so our agenda for today is want to bring you to how Minitab will help you to run or to involve or to start your journey into the predictive analytic world. So now everyone can be a data scientist with the additional module provided by Minitab. So for information with the latest Minitab, adding the new algorithm. We call it, this one is a multivariate adaptive regression spline or MARS. And then hopefully for this time round, I will touch a little bit about the mask. If let's say you want further on the mask, I think we combine to another webinar for the mask. And then since our webinar only 1 hour, so for sure I cannot show all the available features for predictive analytic, but hopefully you will give some idea to start your journey into the predictive analytic worlds. So something like if let's say you already have a some problem, like you need to handle the larger data set. Larger data set means to that not the only observation. Maybe we can go for the multi-dimension data set, something that one. And then maybe it will be complicated data set. So if let's say you have faced that kind of problem, so I think yes, maybe the right time for you to explore more on the predictive analytic alongside with the traditional statistical like the visualization, SPC, DOE, and so on. Since predictive analytic has some very powerful for today worlds, and then to use the model for development and improvement. Maybe come side of the us think about what is the models. Okay, for example, in the manufacturing, basically we start with the process is created from the supplier, measure the process input to determine the relationship to a key output. So maybe engineer find the right input and the model time needed to have a good fit for making reasonable prediction of the output. So the model is deployed, okay, and they're connected to the flow of new data to make the prediction. So it's something like starting with your supplier measure some input, and then from a lot of input, you want to know the most important input, and then from there you want to do some prediction. So in a simple way, maybe a predictive analytic can be after you do the something process stability in control process, maybe you want to do the prediction. So maybe from there you can get some input, and then maybe you can create the, we call it is a future control chart to know about, to see your stability or something like one. So in the predictive analytic module, actually they will provide you some we call it some idea or some simplified way to get or to solve your problem. So for us in the Minitab, predictive analytic is not that new, okay, but some lately Minitab added the new advanced algorithm available right now in the Minitab statistical software. So that's why we have a lot of case study, and then the one is two organization already use the predictive analytic to solve their problem. Okay, so if let's say you want to move further on this story, maybe you can spend some time to go to this link. I will pass it into this about to the link for all of to this case study to get more further on this case study. Okay. Okay, so hopefully you spend some time to see on this one. Okay. Okay. Okay, so predictive analytic is something like you learn from your historical data and to generate insight about your process, your product, or your service. So predictive analytic enables you to build the predictive model to make the prediction on the future outcomes. Maybe predictive analytic will help you to answer this question like what is the key drivers that influence the needs for maintenance on your machine for predictive maintenance. Maybe you want to find the root cause of the defect in my process. But I think it will be some question. The root cause of defect, maybe you can solve by the FMEA, maybe you can go for the simple project, but that one is I think that one it will use something like brainstorm tools, but for the predictive analytic will help you if, let's say, you can convert from your information, that discussion, to the data measurement. Okay, whether it's something like numeric data set or something like you have the text data set. So predictive analytic will cover on that thing. Okay. And then this one is some benefit of use the predictive analytic. Okay, so I can simplify that. The one is during implement the predictive analytic, we have two phases. Maybe you want to start with your historical data. Okay, both of this phase will start with the historical data, and then you can apply the predictive analytic algorithm, and then you will generate that model, and then from there you can model can explain how influence each of your factor, or maybe how influence or interaction between your factor into your response. This one is the first phase. Maybe after you get it, you know about the influences, the every factor or every response or every predictor into your response, maybe you can go for the second phases. We call it that one. If you try, okay, you generate the models and then you apply to the new data set coming to get the generate prediction. Okay, so mean to say that predictive analytic can be two situations. Maybe if I want to know about that predictor and response, and then after that you want to do the prediction. Okay, and then maybe most of us always believe that, or something like believe that SPC will be the good philosophy or good we call it the framework to improve our process. Okay, I'm not denying it. The SPC is success theory, but maybe okay, because we already in the new era, we knew something like transformation digital. You use the smart device. You face it with a lot of variables. You can trace a lot of the data set coming. Maybe SPC is not able to handle the kind of the data set. So that kind of this situation, maybe predictive analytic will help you more on this. Okay, beside the SPC, you do the SPC, but now SPC using the predictive value. Okay, from your predictive analytic, maybe they will help you on this one. Okay, and then maybe this one also I already have optimization, okay, but some problem during the design of experiment, okay, maybe in costing, maybe you're not sure about the what is the range between the level 1, level 2, what is the maximum aspect for this every variable, something that one, okay, during the DOE. So maybe PA will help you in terms that kind of problem. For example, in the PA, you can easily identify the most important variables. For example, if let's say you go for design experiment, you need to go for the screening design. So you combine all together of the predictor or factor, and then maybe it will be difficult to you to stop the production to run the experiment, or maybe it could need to some lot of time or some lot of the cost okay, to do the screening design. So that's why predictive will help you on in term to identify the most important variables based on the relative variables important. And then some problem regarding or during the DOE is something like you never know about the spec limit for every factor. So maybe from the finding from the predictive analytic, we help you in terms to determine the spec of each predictor. It way you can get from the we call it this partial dependency plot to get the minimum value or maximum value for each predictor. Okay, so mean to say that maybe for the SPC part, you will be the second place. Okay, you get the best result, and then you generate the prediction based on the prediction value. You try create the new control chart, okay, SPC chart, to see the what happened, okay, is for the another quarterly or monthly, another next year or something that one. So you can see on this one, or maybe you want to more explain it about the level itself, level 1 or level 2 for DOE, or maybe you want to just little bit only consist of 5 factor from the 20 factor you discover for your process. So predictive analytic will help on this one. Okay. I cannot say that predictive analytic it will be the best. No. Maybe it will be some further analysis for you. If let's say you already use the SPC and then you already use the DOE. So predictive analytic will be pair between that theory. Okay. And then here, something with we need to know about the predictive analytic. We have some new term maybe, I'm not sure. Okay, that one is something like, we call it the validation. Okay, validation here is to prevent to build the models with low predictability. So for this validation is something analogy, you have a set of the data set. Okay, you divide your data set into 2 parts. The first part will be the training, okay, where you can create the models, and then another part you use that to assess the performance of your model. Is it higher accuracy or lower accuracy? So we need to say that one set of the data set, how many data set you have, okay, you divide by the 2. It consists of the training or test data set. But in order to split into 2 groups, okay, we have a kind of the methodology. Maybe you can go for the leave one out cross validation, or maybe you can go for the K4 cross validation, and then maybe you can go for the validation with the test data set. So we have these all available in Minitab currently. Okay, so the type of the validation, it will depends on your data set. Our suggestion, if let's say it's more data set, you can go for the leave one out cross validation, where you have one sample via the test, the others via the training set. But if let's say you have a moderate amount of data set, you can go for the K4 cross distribution. So K here is how many group you want to split to your data set. Okay, and then after that, you will go for the validation with a test data set. Maybe you go for the 70%, we are the training data set. Another 30%, we are the test data set. Okay, but I think our customer always ask, which is the best? Okay, the best, it depends on your data set. Okay, it will be the best is a depend data set. Okay, validation is important because you want to fitting. Okay, so before this, maybe you will go for you fit the models, and then you collect the new data set, okay, based on this model. So it has something like overfitting. It's not so fit. So that's why they come out with the validation. They valid with the same data set. Just only different type of the validation. This one, okay. That one is a depend on your data set size. Okay. And then this one is the algorithm available in the Minitab statistical software with the additional, we call it the predictive analytics. So this one is a classification algorithm, or we call it, or maybe you can go after this, you can go machine learning. We have a two, it's a supervised learning, unsupervised learning. It's simple thing. Supervised learning is something like you want have an output. Okay, you have for the output or you have the response. But unsupervised learning, your aim will want to do the grouping. Okay, you want to group that data set only. Okay, so in the supervised learning, actually they divide by two. It's a classification algorithm, a regression algorithm. So as we know, classification is referred to text data set. Okay, you accept or reject something that one. Okay, it's not measurement data set. But if let's say you go for the regression algorithm, it will be a measurement data set. It's something like you can measure the weight, the length, the strength, the brightness, or something that one, the cost. Okay, so all that thing, you can go for the regression algorithm. So regression algorithm here, maybe you can so go for the simple regression. You already do, is it? The simple regression. So maybe you can consider you already do the predictive analytic. Okay, so maybe you can go for the multiple regression. Okay, so we have the partial square, and then the new additive with the starting with the Minitab 19, I think that one is the tree-based method. We call it the CAT. It's a classification and regression tree. And then we have the random forest, and then we have the TreeNet. Okay, and then the new editing is we add multivariate adaptive regression spline, or we call it the MAS. Okay, for the tree-based method, include the CAT, random forest, and TreeNet if available for the boost supervised, is whether it's classification or a regression. Okay, so we go more after this one. So all these are available in Minitab statistical software. Okay, so we go for the tree-based method. Okay, the tree-based method is something like series of if-then rules to create the prediction from one or more decision tree. Okay, so basically, tree-based is recommendable, accuracy, and easy of interpreting. Okay, that one is, we go for the regression, you have equation, but for the tree-based, you have the tree. Okay, whether it's single tree or multiple tree. Okay, so compared to the linear model like regression, okay, tree-based machine learning algorithm provide deeper insight. Maybe you can map the non-linear relationship. Maybe you can have visualization, okay, or complex interaction between a predictor, and then maybe you can handle the larger data set, and then tree-based will be performed better if let's say you have a missing value or outlier value. Okay, if let's say before this you're already familiar with the regression line, you have assumption. Okay, to need fulfill. If let's say you have a lot of outliers, it will take some time, okay, to get the best equation, the fit equation before you use them, do the prediction. So for this kind of the issue, okay, missing value, outliers value, tree-based will handle it. Okay, no need a lot of time to handle all that thing. Okay. So Minitab tree-based predictive module, they have conceived with the tree, okay, classification and regression tree is a cut, and then we have the random forest, and then we have the TreeNet. Okay, but for the random forest and TreeNet available in the predictive analytic module. That one is the additional cost you need to enjoy this predictive analytic module. Okay. This one is we go for the cut first. Okay, so before we go for the random forest, before we go for the TreeNet, we go for the cut first. Okay, cut is the original author from the Friedman and Awesome, Stone in 1984. Okay, and then the cut is a works like you split, okay, the response, the Y variable into two, based on the prediction, into the two group, whether it's a low or high. Okay, maybe whether it's the something like percentage. Okay, it will depends on your response. Okay, cut can be other classification. Cut can be other a regression tree. It will depends on your response. And then the diagram of the cut will be different. If let's say you go for the cut classification tree, okay, so you will see on the percentage. Okay, but if let's say your cut, your Y, your response regression measurement data will be used the cut for regression. So you will see the mean and the standard deviation on this splitting. Okay, so cut will know model assumption. No need to check the residual, no need. Okay, and then model follows the data and then easy interpreting. Okay, is we'll go use the medium to the large data set observation. So we go more on this cut, how to explain it, the cut. Okay, so this kind of the terminology. Okay, the first here is we call it the root node. Okay, the root node is the node at the top of the tree. Okay, so from here, you can get the splitter. Splitter here is the decision rows that define how the nodes is partitioned. So for this group, actually is partitioned by the predictor weight is a less than 396.5. Okay, or here is a more, the weight more than 396.5. Okay, and then we call it that one is we have the tree splitting. Okay, a tree splitter occurred at this weight and then occurred at this speed. Okay, and then this one is we call it the terminal node. Okay, that one is the important here. We have the three terminal node here. Terminal node means that a node has no sub branch. Okay, you cannot see the another splitting. Okay, so this here in the terminal node. Why important? Because in the terminal node, actually you will see the prediction value. You will get the prediction value. For this case, it's the mean. It will be your prediction value based on the mean. Since this one is the regression, classification tree. If let's say you go for the classification, a cut for classification, so it will see on this. Okay, you will see like this one in the percentage. Okay, the works is the same. Okay, the objective will be the same. Okay, how the works it will be the same. Split into two group. Okay, split by the predictor, but just only different information, or we call it different matrices available between this one. Okay, so actually that one we have root node, you have the splitter here. Okay, I think is engineer is more interest on this. Okay, splitter, because that one is you can get the minimum number of each response. Is a predictor. Okay, you want to set up the limitation, spec limit, lower or upper limit for each predictor to do the some DOE, something that one. Okay. Okay. And then how to use that cut. So the same, okay, you go for this one. Okay, for example, the rules one. Okay, here. Rules one is a group one. Okay, terminal node one. It coming from the weight is a less than this one. And then the predictor value of the machine manufacturing cost, it will be 79.01. Okay, for the second rows here, okay, it coming from the weight for this value and the speed less than this value, and the predictive value for manufacturing cost, it will get this value. So same go for the row 3. So mean to say that if let's say your tree have a lot of terminal nodes, okay, terminal nodes, so you have a lot of combination of the decision row you will get. Okay, so if let's say you go for 30, 20, okay, 20 terminal nodes. So mean to say that you have a 20 rows. Okay, so from each 20 row, maybe you want to find the lowest number of the predictor manufacturing cost, maybe the highest number of the predictive value for the manufacturing cost. So it will coming from where? Okay, is it from the weight this value and the speed this value? So from these three terminal node, so if let's say you look on the highest value of the manufacturing cost, so it coming from the when your weight more than 396.5 and your speed is less than 60. So you will get the highest value of manufacturing cost. If let's say you want to look on the lowest number, just only from the weight, okay, is the less than 396.5. Okay, so this one is how you can get the decision rows or something business role for your company, or you want to do some decisions based on this decision, or based on this terminal node. So that's why in the cut, we consider it's easy to interpret. Whether you group that this kind from here, from this predictor, you will get this one. Okay. And then we try with this one case study here. Okay. So this case study is actually a paper manufacturer seeing the process is very non-stable. Okay, they provide the contour chart and they creating unacceptable defect rates. Okay, so they use the current data to identify which factor are contribution to this variation in the bleaching process. And then from there, they want to do prediction, the expected brightness in the operation. So during that, the response is the Y, is the brightness, and they consider the other predictor is something like production rate. They can consider the discharge, caustic, and so on. Maybe they get all this information when they use the smart device or something. That one, I'm not sure is it correct or not, smart manufacturing or some so on. You use the sensor to get all this information. So that's why they will capture all this information, and then they try with this simple predictive analytic. Okay, so I will go to the tech data set. Okay, hopefully you can see my screen. Okay, for the Minitab. Okay, so if let's say, okay, you can type 1 in the chat. Okay, now I open the Minitab. Okay, oh, okay, so I can proceed. Thank you. I can proceed how to get it, the card in the Minitab ticker software. Okay, for those not maybe you not already purchase the additional module for the predictive analytic module. No worries, you will able enjoy the card. How to get it? You go for the start. You see the predictive analytic. We go for the classification or a regression tree. Okay, so for this case, we have this one. Okay, we have the brightness. It will be our response, our Y. The others production rate up to the bleach, it will be our predictor or factor or something you call the parameter and so on. Okay, that one. So how many data set? Maybe you can go for this one, right click, and then you will go for the worksheet information. So in this worksheet information, they have the 2875 data set. Okay, for this case study. And then all the variables or the column, it will be the numeric. Okay, so how to get it? Go to the stat, go to the predictive analytic, you choose the regression. Since our brightness, our response is the measurement. Okay, so you go for the regression. For this case, it will be the brightness. All this information will be the continuous predictor. And then you click OK, so you will get the cut. Okay, so we'll take, okay. So on this one, you will see that 24 nodes cut. Means that you have a 24 terminal node. Means that you have a 24 suggested rules. Okay, you have a 24 decision. Okay, so mean to say that from here, you will get the 24. How to get it? I will do, go to stat, go to predictive analytic, you choose the regression. Okay, for this case, you choose the brightness, you choose the predictor, and they click OK, so you will get this information. Okay, so for this information, maybe you can go for the R squared. Okay, R squared to get the optimal one, meaning that will generate the optimal tree. Okay, so maybe you can see that this one is the number of tree. Okay, so you can go one by one, but Minitab we provide you, we consider that the optimal tree. The optimal tree here, we have the 20 consists of 24 terminal node. If let's say you want to go further, you can go for this one. Or maybe you can go for the select alternative 3. Okay, so on this select alternative 3, you have a 24 terminal node. So you can see on this terminal node 1. Okay, terminal node 1, that is conceived from the production rate. It's coming from or less than 100.23, or maybe you can get from the production is less than 71.7. Or maybe you can go for the another terminal nodes. Okay, so you will see another combination. So you will go for the terminal nodes and so on. So maybe you can go for the last terminal node is 24 here. Okay, sorry, I think this one is the 24 terminal node. So 20 terminal node 24, it from the production rate. Okay, it's from the production rate, this one, the product, the H2O, this one. Maybe we'll help you on this, simplify that terminal node, simplify your tree with the highest value of mean or lowest mean, or go for the optimal nodes. Okay, so for this case, maybe we go for the lowest mean. Okay, so we got the lowest mean. So after you choose the lowest mean, means that we have you show the 5 highest lowest mean for this case. So it consists from the terminal node 1, terminal node 2, terminal node 4, terminal node 5, terminal node 6. It will be the lowest mean of the brightness itself. Okay, so maybe from here you can study on this level. Okay, this group H2O to decide which one. Maybe you want to study on the highest mean. Okay, so it's highest mean from the terminal node 50. Okay, and then go for the terminal 17. Maybe you can go for the 21. That we simplify with this high nodes. Okay, or maybe you can get from here. Okay, right click. Okay, you can see the highest node, the lowest node. So you will see like this one. So many times you can see they will change to the black color after you click on the terminal node. So it will help you on this one. Okay, and then the other thing, interesting part, they will have the R squared here. Since the regression, they provide the R squared. And then the test is the 71, quite good. Okay, quite good for this model. And then the important here is this one. The most important factor or predictor into the brightness, it will come from the production rate. Okay, and then followed by the H2O. So the simple way, something happen into the production rate will be impact into your brightness. Okay, so no need to consider the others predictor. Maybe you can focus on the production rate. Okay, so but the what value of the production rate? So this one is a variety of the value of this production rate. So what to answer that question? Maybe you can look on this node by node. Okay, node by terminal node here to look, find the best setting for this production rate. If let's say you want to further on the lowest brightness or highest brightness. Okay, so this one is how you can do or you create the card, okay, to solve your problem for this case. Okay, and then here, okay, you already satisfied with the 24 terminal nodes, and then the next you want to do the prediction. Okay, for example, you have the new data set coming. Okay, you already have a data set coming. Okay, the new data set coming, and then you want to use this 24 model, okay, card model to do the prediction. You just go scroll down, and then you can see the predict button. Okay, you can go for the predict button. Maybe for this case, with the column, okay, production rate, okay, your discharge, okay, pH, your caustic, okay, magnesium, H2O, okay, maybe here is 2O, okay, here is conductive, PT, here is a bleaching, okay. So you are satisfied with this all, and then you click OK. So you will get the fit value. Okay, you will get the fitted value or predictive value in the worksheet, not the in the output pane. In your worksheet with the fit. Okay, the name for the prediction in this column, it will be goes for the fit. And here they provide the terminal nodes. Okay, mean to say that this first combination is coming from the terminal nodes 19. So the predictive value will be 81. This one is from the terminal node 30, this value, and so on. So they will get you this information. Okay. Okay, so for this case, you already have the basic, we call it the basic tree. But why we need have additional advanced models like TreeNet or random forest? Okay, so we go back to this one. Okay, to go back to this. Okay, you see that this one is predictive analytic model. Why you need have this? Because okay, we want to have some balance model between the bias and variance, since the cut only one tree with the 24 terminal nodes. So we believe that when we have a lot data set, okay, we can rely more reliable your result. Okay, so that's why they come up with we call it the assemble model. Okay, to try minimize the variance and while having the bias to remain the low. It's a balance. Okay, we want to balance that model. So they come out with the random forest and the TreeNet. Okay, so that one is show to you need have a multiple tree, but in different multiple tree. Okay, different methodology to get that multiple tree, to build the multiple tree. It's a different way between the random forest and the TreeNet. Okay, so the random forest actually they provide some, like we call it is here. Okay, use the bootstrapping sample. Okay, bootstrapping sample means that you have a data set. Okay, you take it 100 data set and then you build one tree here. Okay, and then you turn back the data set into the original one. You take it again 100. Okay, and then you create new tree and so on up to how many data set you have. Okay, mean to say that maybe between the 3.1, 3.2 have a similarity since you back to the original one. So this one is, we call it, this one is the bootstrapping sampling. How to get it, how to random forest works. Okay, cut only one tree, random forest multiple tree. How to get the multiple tree? They use the bootstrapping sampling method. Okay, so from here, how to get the predictive? Okay, so if let's say go for the classification tree, random forest, we go for the majority rows. If let's say random forest, go for the regression. Okay, regression, random forest, so we go for the average row. So combination of each tree here. Okay, so that's one is the first that will go for the random forest. Okay, and then we have another way. Okay, we have another way. We call it the TreeNet. Okay, TreeNet is consists of the sometimes we call it the gradient boosting. Okay, to how to multiple that tree. Okay, how that they start with the equation, something that start with the average of response variables. Okay, and then they use the arrow from here to build the tree. Okay, and then they come up with the new prediction, and then they come up with the new tree from the prediction. And then they come up with the new prediction from the fixed tree here. So that one is, we call it the boosting. How to get it? This one is boosting, by the boosting method to get the TreeNet. Okay, so for this case in the TreeNet, actually they provide the high performance. We believe that TreeNet we give you the high performance and then more complex models that can consider of several hundred small tree, and every tree contribute a small to the overall models. Okay, but in the TreeNet they will give you another thing, is we call it the partial dependency plot, where you can see the plotting. Okay, what is the different, what is the contribution for each predictor into the response. Okay, so I think I go to the Minitab, easy to see it. this one. Okay, first I try with this, the same data set. Okay, the same data set. Okay, just different algorithm. We start with the regression. We start with the random forest. Okay, the same step. You go for the predictive analytic module, and then you can see the random forest for the regression. So for this case, the same. Okay, you go for the brightness. Here is all the continuous predictor. You go for the select, and then maybe you can go for the radiation. Okay, they click OK, and then you click OK. I just go with the default setting. Actually, you can go manipulate the parameter for each models. So for this case, in the based on the random forest, you will see that we have this one. Okay, the R squared is higher rather than cut just now. Okay, and then the relative important variables, you can see production rate, it will be the most important, followed by the H2O, same as a cut just now, but the increasing of the R squared. Okay, so we go for another models, is a TreeNet. Okay, TreeNet. So maybe you go for fit this one, the brightness, and then here is the continuous predictor. You select all this one, click OK. Okay, so they will provide you the TreeNet. Okay, on the TreeNet, they have the R squared here. Okay, so and then the R squared, you can see the R squared here is the highest rather than random forest just now. Okay, you go for the test. And then you can see on this one, okay, on this relative variable important, production will be the most important predictor to the brightness. Okay, and then here is followed by H2O, caustic, and so on. And then they provide you some this one. Okay, we call it the partial dependency plot for each predictor here. Basically on the production rate. So you will see that, okay, start with the production rate. Maybe here is a 40 something, that one 38. Okay, so go for the here is for 50. So they have the static, okay, static brightness. But once your production rate is increased, okay, increase, so the brightness will be increased here. Okay, at that time they will decrease. Okay, production rate increase, but the brightness will be decreased, and so on. So this one, they provide you the production rate, they provide you H2O, and so on for each this predictor. So you can get more insight on this partial dependency plot. Okay, using the predict TreeNet. Okay, so from the cut, okay, okay, I go for the basic tree. Okay, you go for the basic tree. Okay, you will see on this summary. So you go for the advanced multiple tree. Okay, you will see increase the R squared here will be increased, and then you go for the TreeNet will be increased also for this. Okay, for this tree. Okay, so increase the value of the R squared for this case. Okay, maybe we try with the Mars. Okay, Mars, I go to the Mars. Okay, Mars is the new editing. Okay, it's the new editing from, I think it's a Minitab 21.4 for the enhancement. And then we have the multivariate adaptive regression spline. Mars, it with some similar, not totally similar. It seems similar with the regression since they provide you the equation. But the equation we in term the basis function. Okay, not the straight line. Okay, we give you the equation, but in the basis function. So for the Mars actually. So if let's say you want to go see this one, I try with this Mars. Okay, go back to this one. Okay, go to use the same, okay, just different algorithm. So Mars, we try with the Mars, the response, the brightness. Okay, for this case, select all and they click OK. So you will see the Mars. Okay, so you will see the Mars the same. Okay, okay, so you can see that the regression equation. Just now for the cut, random forest, TreeNet, you face with the tree. Okay, so now you will get the regression equation, and then you, in terms of the basic function for this. Okay, you will get the brightness on this, and then maybe you can see on this R squared, it will be increased. Okay, and then the relative important, it will be have the production rate, it will be the most important, followed by the H2O. So basically, why we need have the advanced algorithm like random forest, TreeNet, mass, because we want to increase in this R squared. Okay, so we believe that only one tree is maybe the last. Okay, maybe you increase multiple tree, so will be increase the R squared. Okay, and then maybe you choose to others, maybe you want to advance, okay, but you want to have equation, so you can look on the Mars algorithm. Okay, but no worries, you no need go one by one, since Minitab provide you this kind of the features. We call it automated machine learning. So automated machine learning is something like Minitab will help you create all the available algorithm, and then Minitab will give you the best algorithm based on the highest value of R squared. For the regression, if let's say you go for the classification, we go for the ROC. Okay, it will depends on this one. So for this automated machine learning, actually it will consist of the regression equation, regression, multiple regression, cut, random forest, TreeNet, and the Mars, and then they will combine, compare together, and then Minitab will give you the result, which one is the best. Okay, so we show on this one. Go back to the Minitab. How to get it, that one. So you go for the predictive analytic, and then you can see automated machine learning. Okay, so choose the best. It's a continuous. Okay, for this case, we use the continuous, since brightness is measurement. Okay, you go for the continuous response. For the response is the brightness. Here is the all information here, and they click OK. So it will take some time, since they provide all the Minitab generate all the module, all the algorithm. Okay, but Minitab will provide you the R squared. Okay, the highest R squared will be the best model. They compare with the highest R squared. Okay. Okay, so now they will go, Minitab will form all this information. Okay, will they give it you this all information. So this one is the model selection here. So based on this one, it's a Mars, it will be the highest value of the R squared. So in this context, maybe you can accept that the Mars algorithm will are the highest value of accuracy to do the prediction, or maybe the Mars will be the the best model. Okay, to get the new prediction. Okay, so it's satisfied with this one, or maybe you don't want, so you can go for the select and alternative models. Okay, that one is the optimal by Minitab suggestion, or Minitab default setting, or Minitab option. Basically, if let's say you don't want, okay, you don't want use that, okay, maybe you want to compare with your own expert or something that one, so you can go for the select alternative 3. Okay, maybe you can go for maybe you look on the card first. Okay, you can display the result. Maybe you don't want card, maybe you want go for the multiple regression, you can display the result, and then Minitab will generate that result. So no need go to stat, no need go to stat. You choose the regression fit. No, so you just go back to the discover this one. You can select an alternative models for this, and then Minitab we provide the information. Okay, they're using, and then the regression equation maybe, and then look on this all this one. Okay, so all these are available only on for predictive analytic module. We call it the automated machine learning. Maybe can be the second opinion, okay, or maybe the first opinion to give your idea to start to find the best model for you. Okay, this one is all available in this predictive module. So for those want to try, so no worries, you can try with the step by step, try with the cut first. If let's say cut okay, so you can proceed, or maybe after this you can consider with the predictive analytic module. Okay. The same, why we need that one, you want to see, or you want to see the relationship or influence between the predictor, okay, between the predictor into your brightness. Once you get the best one, you will get the fitted result, okay, the prediction result. So once you get the prediction result, maybe from here, you can go to the something like back to your basic one, okay, the traditional one, go to the IMR, okay, maybe you can go for the IMR, for example, okay. This one is a futures control chart. You will see. Click okay. Okay, subgroup. Sorry, this one is go back to this one. For example, this one is how you want to apply it, okay, or use the PA models, okay, for this one. Okay, by the fitted, click okay. Okay, so you will see that this one, okay, in the future, if let's say you doesn't do anything about this predictor, so your process is looks like this one. Okay, so maybe you do the improvement side, and then you will get the generate the new data set coming, and then you can form your control chart, and then you can see the future of your process. Okay, before you ended, or before you have your own result. Okay, you can have the future prediction control chart for this case. Or maybe you can back to this class, and then you can see what maximum value, okay, for this control chart. Okay, sorry, for each predictor, okay, what the maximum value, this one maybe be your level in your DOE, okay, and then how many variable actually you can consider to run or to define your design of experiment, okay, because we believe that if let's say you have a lot of consists of a lot of factors, so maybe you can have a lot of costing, timing, and so on. So from predictive analytic, at least, okay, now you just only focus on the maybe 3. Okay, 3 power of 2, okay, 2 power of 3 with the 2 level, only 8 replication. Without replication, 8 run. So maybe you can go for this one. So maybe PA model will help you in term reduce the cost, okay, and the timely, you will get the same one. Okay, in this simple step, you will get the result one. Okay, so I think I go to this one. Okay, already done it for the prediction. So every models, you scroll down, and then you can get the prediction button. Okay, sign, and then you can do, and then you will get the fit in the worksheet, not the output pane. Okay, in the worksheet, you will see the in the worksheet. Okay, and then if let's say have a time, okay, so we have a 1 hour. Okay, so if let's say you have a question, let type into the chat box or Q&A box. Okay,